In this DeBacco University video, I'm going to go over the importance of valence electrons, what they actually are, and how you can use the periodic table to determine them for elements you might be familiar with or not familiar with, as long as you know what group or family they're a part of. All right, as we can see here with these valence electrons highlighted in red, we're looking at the outermost electrons of this particular atom. So valence electrons are just that. They are the outermost electrons of that atom, and they are the electrons that are most involved in chemical bonding as well as reactions, because those outermost ones are what's going to come in contact with the outermost electrons of another atom, as we see here in this carbon dioxide molecule. Now, what are valence electrons? They're in the highest energy level or shell of an atom. They're the ones that participate in chemical bonding, and they're responsible for an element's reactivity and bonding behavior. We could see them drawn here with the little dots. They're also involved when we go to calculate electron configuration, and we can see them here in this simplified diagram with, again, them being here on the outermost ring of this particular atom. Now, what is their importance? So if we're looking at the importance here of valence electrons, well, bonding. Atoms bond to achieve a full valence shell, typically 8 electrons, which is called the octet rule. I'll show you one example where that is not the case. Reactivity, elements with 1 or 7 valence electrons are highly reactive, and that's going to be on the ends here of our families of our periodic table. And then periodic trends, elements in the same group or family have the same number of valence electrons, which it explains why they have similar chemical behavior. So let's take a look at that periodic table here. I'm going to put myself here where the valence electrons are because they change. So we're going to kind of ignore them as far as this little helpful tip applies. So the families or groups for valence electrons, we can see the alkali metals all have 1, alkaline earth metals all have 2, 3, 4, 5, 6, 7, and then our noble gases have 8, except for, here's the exception, for helium has 2 valence electrons for a full outer shell. Pretty much most other elements are going to favor 8, especially as you get beyond here where you're talking fluorine, and the halogens have 7, very reactive because they're 1 away from getting to that full shell of 8. And then our alkali metals here with 1, they really want to get rid of that 1 because typically the next shell in will have a very stable form of electrons. So hopefully you understand what valence electrons are and how to use the periodic table to determine what they are, at least for the major groups and families depicted here.